Hi, so this is a quick introduction to MPPT solar charge controllers by Victron, and also the app that covers these and other Victron products with smart technology. In other words, products which have Bluetooth built into them. So if you see smart in the item description, then you are looking at a product in the Victron range which has Bluetooth compatibility. And there's a free app you can download, and that's what I'm showing you here. So you don't even need an actual device to find out what the app is like. You can just go to the top left hand corner here, click on, and then go to demo library here, and then you can just scroll down, find the items that you want. You can see there's every kind of product in here. There's lithium batteries, there's inverters, chargers, and we're going to click on solar charge controllers. And then as you can see, the top ones are blue solar chargers. Now these may be units which have got a dongle addition which allows them to be Bluetooth compatible, or you can buy the smart ones which have the Bluetooth inbuilt. And if we pick one as an example, let's go with the Smart Solar Charger MPPT 100/30. The 100 is the voltage and the 30 is the maximum charging amps to the battery. Any excess would be worked off either as heat, or the panels themselves will be switched off depending on the situation. So first things first, you can see in this mock-up, you can see that the wattage in the current instant is shown in a kind of dashboard. Scrolling down, you can see voltage of the solar panel array. And that can be up to 100 volts. The higher the voltage you have, the more efficient the system will be, but obviously there are things to consider when working in high DC voltage. The current is the current entering the charge controller. And then if we scroll down a little bit further, you can see this is a really useful diagnostic. Voltage on the battery. For most of us, the voltage of the battery doesn't indicate very accurately the actual state of charge. It will be either artificially high when it's being charged, or artificially low when it's under a heavy load. It may well drop by, say, half a volt under 1,000 watts, depending on the size of battery bank. So you need to bear that in mind with your low battery isolation settings. Then we have the current going into the battery, and below that the state, and this is the state of charge. And like any smart charger, this refers to the three main stages of charging, being bulk, where most of the charge is going into the battery at full tilt. There's no fear of boiling the battery with too much power. And then once the battery is almost full, around about 80%, the voltage will be increased, or at least held high, usually increased, and the amps will be tailed off in order to achieve what's called the absorption charge, which is designed to ensure that the batteries receive a full 100%, and sometimes even more than that, recharge. And then you have the float function, which is where the charger is used to keep up with the load up to its maximum rating. So for example, if a battery is in float mode and you put 25 amps load onto it, and the charger is capable of delivering that, it will do, therefore maintaining the battery in a 100% state of charge. Then we have virtual load output, and this is basically one of the features of the MPPT charge controllers. They have the option to switch things on and off in their programming, which we can look at now. So going over to the program gear wheel, you can see things like where you can put in your charge settings, float, usually the bulk and absorption settings, the type of battery, and things like repeated equalization, which is a controlled boil of the battery to stir up the electrolyte. Then you have things like street light function, which I use on my own at home. And basically, there are various ways that you can set up the system to switch on lighting or other loads for a given period before or after sunset, and with a given delay as well. So on mine, for example, there's a 5-minute delay after sunset, and then my garden lights come on for a couple of hours. Then you have other functions which I'll leave you to look into through the manuals. And then VE Smart Networking. And VE Smart Networking is a really important tool in the MPPT range. Basically, this is a way of different smart components talking to each other. So if you have a VE Smart network set up, the for example, battery monitor may be talking to other items such as the MPPT charge controller and sharing information so that they can make adaptations to the way they behave. So for example, on my lithium batteries, the smart shunt battery monitor that I have fitted broadcasts the temperature of the batteries on Bluetooth, and the solar charge controller is set up to not charge those batteries below a certain voltage, below a certain temperature, thus avoiding cold charging of the batteries, which is a big no-no with lithium batteries, and one of the reasons why I choose a particular brand that has inbuilt heating. So that's the settings. One of the super useful features of a MPPT Victron product is that in the history section, you can get that day's maximum and minimum data. So here, for example, you have the total output from the panels in kilowatt hours. Then you've got your maximum wattage of the panels that day, your maximum voltage, similarly your high and low battery voltages, and that's a really useful diagnostic tool. You can tell quite a lot about what's been going on with the batteries by using that data. You can also touch any of the bar graphs, and you can see here the bulk, absorption and float stages of charging are shown both as a time scale and a percentage of the charging that's occurred that day, and that again, ideally with lead acid batteries, you'd be looking to achieve all three stages every single day. With lithiums, it's not quite so important, but it's good to get them have these 3-bar colours at least every couple of days in order to synchronise the batteries properly. And this information scrolls back 30 days, so you can actually see, as the seasons change to some extent, what yield has been changing. Now there's another function up here. This is the share button. Basically what you can do is download an Excel document, and that is lots of data which you can open up as a spreadsheet, and if you were to say take 30 days data and then download that, and then the next month you could take another 30 days and you can see exactly how your system's performing. Finally, useful diagnostics for working out how your system's operating and under what circumstances would be this trends graph. Basically, this allows you to display different things, so you can see battery voltage and current. Some things are grayed out because this is a demo product, but what I tend to use is battery voltage on here and solar wattage on the other side, so you can see how the batteries respond to the power which is being produced by the panels. Now, where that's useful is if you are, for example, trying to work out what particular loads will do instantly to the battery voltage. So say, for example, you've got an inverter charger on the system which is pulling 2.5 kilowatts, and you want to work out where you should set your low battery isolation settings. If you just say, okay, I don't want my batteries to go below 12.5 volts because they're lead acid and that's about right for me, then the problem with that is that your system may reach that voltage artificially quickly because of the voltage being under pressure, as it were, from the load. So if you know that your battery voltage drops by 0.5 volt instantly, then you know that that reading isn't really real in terms of the battery's state of charge, and therefore you can adjust your settings accordingly. So you may tell your inverter charger to switch off at 12 volts, but in reality it's actually more like 12.5 as soon as the load is switched off, and the damage that you believe is being done isn't actually being done. So that's a quick overview. Why choose MPPT charge controllers by Victron? Personally, I've bought half a dozen of these for various off-grid projects that I do, and I have found them to be very, very well made, very good quality product. The Bluetooth is the only thing that lets them down in the sense that it's not a very strong signal. Some are better than others, so there are particular ones which I look at. Luckily, through the smart networking, you can actually uh, have a total system output. So, for example, you can tell um, what the output from the panel that you're looking at is, or its controller is anyway, but it'll also tell you the total for all the other controllers on the same smart network. So you can use it as a fantastic diagnostic tool. It's well made, and of course, being MPPT, it will actually maximize the output, the all available output power from the panels. So it's a bit of a no-brainer really, guys, if you're looking for solar. Thanks for listening.